The last piece with word problems, there's going to be this video and one last one, but we're all going to do applications from here on out. So our first application of exponential growth and decay is what's called your basic exponential growth or decay model. This should look familiar. You definitely do this in Algebra 1. I actually helped my son with it about a month ago. So I want to make sure that you have this formula. Write it down in your notes. Pause the video if you need to, so make sure you have everything here. I'm going to explain all the pieces and parts. So when you write an exponential model, the number in the very beginning, this lowercase a, is your initial amount. So we're going to be doing things like we're going to look at money that we invest at a certain rate, or we're going to look at a population that starts at a certain amount. That first value will be that initial amount, what your initial population is, what your initial amount of money is. Then in parentheses, you're either, if it's growing, you're going to take 1 plus your rate. If it's decaying, you're going to have 1 minus your rate to see that we're going to call that the growth factor. If you're putting money in the bank for interest, for example, you're going to do 1 plus the interest rate so that you'll have a base value that's bigger than 1. If you're losing money or losing value, you're going to take 1 minus the rate. Make sure when you write your rate, you always write your rate as a decimal. So for example, if you had something like 4.5%, that should be 0.045. So make sure you are always converting your rate to a decimal equivalent. And then finally, the exponent of your growth factor is going to be time. How much time has gone by? A lot of these problems work in years, but you can also work in hours or even down to minutes or seconds. So first thing I want to make sure you're comfortable with is just identifying growth and decay and the factor and like what's happening with this. So let me go to Delta Math to show you. So your first couple questions are going to be like this. It's not going to want you to actually get a final answer. It's going to want you to identify what's happening. So it gives this following equation. First, it wants you to say if it's growth or decay. So the way that you figure out if it's growth or decay is you're going to look at the base number. If that base number is bigger than 1, it's growing. If it's less than 1, it's decaying. This one's obviously less than 1. And then secondly, it's going to want to know what is it growing or decaying by? What is that increase or decrease? So if it's less than 1, to figure out what it's decreasing by, you're going to have to subtract that decimal from 1. So 1 minus 0.23, which is 0.77. That is going to be a 77% drop. So on your Delta Math, you're going to type in decay and say, well, it's decaying by 77%. If it's bigger than 1, so let me show you a bigger than 1. This is perfect. Bigger one I actually think is easier. So this is definitely growth because it's bigger than 1 for your growth factor. And it's all we have to do for that growth factor is just see how much bigger than 1 is it. Well, it's 0.46 bigger, which is a 46% increase. So I actually think your growth ones take even less work. And again, it'll show you what are we trying to do here? How much did it go up or how much did it go down? So that's the first thing you're going to be asked to do. Those are really fast. Second thing you're going to be asked to do is actually do full questions. So for example, they're going to give you something like this. You have a certain amount of money or people, you have that initial amount. It's going to tell you how much you're either growing or decaying, and then it's going to ask you about a certain time period. So that for this first one, we are starting with $1,000, so that goes in front of the parentheses. We're having a 5% increase. 5% is 0.05. That's going to be our interest, so we're going to do 1 plus 0.05. And then our time is going to be our exponent. And we can truly enter it in the calculator exactly like this, parentheses and all. So 1 plus 0.05 to the 6th power. It will tell you how to round it. A lot of them want you to round either to the nearest penny, or some of them want you to round to the nearest whole dollar. So those are going to be the types of questions that you're going to be asked on this. So the next one, you're starting with $500. You're putting it in a savings account that's earning interest of 0.035. That's how we write 3.5%. And we want to know what's going to happen after 5 years. You're going to punch it in your calculator and you're going to get your answer. If it's dropping, there's a couple different wording they'll use for dropping. So if it says the word depreciate or decline, those are things that meaning that it is going down. So with that, so we start with a car that's $25,000. Unfortunately, cars do depreciate very rapidly. So we're depreciating by 11%. So we're going to subtract 0.11. and we want to know how much the car will be worth in 6 years. So if it is a depreciating, declining, decreasing, decaying, these are all the words they'll use to show that it is going down. You want to make sure you subtract. So 25,000 and then 1 minus 0.11. You also want to make sure you use decimals correctly to the 6th power. So again, it might ask to the nearest penny, to the nearest whole number. That's how much the car would be worth. Same thing for the next one. If it's people, so 345,000 is my initial population. My population is dropping by 3%, so we're going to subtract 0.03, and we want to figure out the population in 10 years. You can't have part of a person, so these will have to be decimal, will have to be rounded and not written as a decimal. So to the 10th power, so we would say after 10 years, we're at about 254,411 people. So what it's going to ask you to do on Delta Math, just to show you, it's going to ask you to do questions where it gives you something like this. We have a population, we're going to tell you how much it's growing or decreasing, and we want to know what the population is after a certain number of years. And you'll notice it does tell you to round to the nearest whole number because you can't have part of a person. So I think actually I'm just going to do the last part of this lesson right now. So that's your word problem applications. We have one last application, which is going to be to write a regression model. You've done this before, but I really think it's helpful just to kind of see me do this on Delta Math. So the last thing you're going to be asked to do is to take a set of data in a table that is growing or decaying exponentially. There's a lot of problems that deal with bacteria multiplying, I feel like, in this particular topic. And you're going to make the calculator come up with the best fitting exponential equation. So the way that we did this, Delta Math makes this so easy, so you're not having to do much entering at all. They give you this data. So after so many hours, it tells you the bacteria. You're going to hit copy values for calculator. Then you're going to open your calculator and you're going to paste those values. So it does all of that for you. You're going to go into your lists under the calculate menu, and you're going to choose the one that is exponential regression. It's going to say EXP in front of the regression. And you're going to hit calculate. And what it's going to do is it's going to give you the A value and the B value for your regression equation. So you're going to type in, let me see how much they want me to round it. They want to round to the nearest hundredth for the coefficients. So we're going to type in, so y equals 460.30. The only part that I don't like about this is I feel like it's tough to remember what's what here. Y equals, what was it, 460.30, 460.30, and then times, and my B value is 1.10, 1.10 to the x power. So we need, I'm going to open up my screen to make it easier. To my x power is going to be, use my caret button to the x power. I don't know if it cares that this is a capital Y. I think I'm going to change it just because that's kind of bothering me. So there's my model. And then the last question is going to say, use that model to figure out how much bacteria is going to be present after 16 hours. So I'm going to grab my calculator and I'm going to type in 460.30 times 1.10 to the 16th power, because they're giving me 16 hours. And it does want the nearest whole number, so 2,115, 2115, and that's what it wants. It wants your model and it wants your approximation. Those are really fast on Delta Math because it will do all of the entering in the table for you. It'll put it into the calculator. Your job is to make sure you just write the equation correctly. You can see you can put it in parentheses if you'd like, and then use your calculator to do the last approximation. And that is the end of the topic. So we've got all the applications done in this video.